human mind, it is extraordinary. It has perplexed mankind for centuries. Inquiries such as how does it work? What makes us think? How do we process, internalize, store, and retrieve our memories? How do we learn? How is information neurally encoded? What exactly are emotions, intelligence, and consciousness? All these questions have been under scrutiny and examination. We will be exploring how the brain learns. There are several theories. Some are academically accepted, while others are regarded as tenuous and unsubstantiated. This presentation will attempt to see through the various principles and hypotheses, and disseminate balanced, researched, and experimentally generated strong correlations to how best people learn. Some of the endorsed principles underlying brain-based learning are repudiated by other researchers, but because they are established and proliferated by brain-based theorists in the field, they will be discussed. However, they should be deliberated upon with an academic provisional eye. Despite theoretical differences permeating this pertinent field, all are united in trying to seek the answer. How do people learn? What is brain-based learning? There are as many definitions defining brain-based education as there are coffee beans that go into making our morning cup of cappuccino. The definition, most objective and accurate, is engendered by Dr. Eric Jensen. He defines brain-based education as the engagement of strategies based upon principles derived from an understanding of the brain. These strategies have derived from neuroscientists, cognitive scientists, behavioral psychologists, neuropsychologists, and neuroeducationalists, to mention a few. All of these fields, disciplines, and domains approach researching and explaining how the brain learns from their academic perspectives. It is no wonder there is dissonance. First, let's scout the common denominators. Emotions play an integral role in learning. In order for students to learn, there must be an emotional connection to it. There has been extensive research conducted on this aspect of the brain. One of the renowned scientists that has contributed significant amounts of data regarding the role emotions play in learning is Dr. Helen Immordino Yang. Physiologically, the amygdala is responsible for our emotion. It is the integrative center for the emotions we feel and how we react from them, as well as motivation. It is responsible for attaching emotions to our memories as well as our survival mode. According to Dr. Hill, the body, emotions, brain, and mind are an integrated system. Emotions are enmeshed in neural connectivity, and therefore, emotion and cognition cannot be separated from one another. Emotions are also associated to the storage and retrieval of information. In order for information to be converted into our long-term memories, there must be meaning assigned to the learning. In order to accomplish this, educators must make the learning meaningful and relevant to the student's life. For example, when teaching students about infectious diseases, showing powerful images of the victims of these diseases, maps of where the infectious disease outbreaks potentially occur, or brief movie clips of scenes showing the result of an outbreak. Ask students reflective and predictive questions such as, what is an infectious disease? Can you name some? What characteristics does an infectious disease have that differs from non-infectious diseases? Do you know anyone that has fallen victim to one? Create a case scenario stating that their local town had just experienced an infectious outbreak and is now under quarantine. No one can leave, and no one can enter. The CDC, Department of Health, and other government agencies have taken over your town. How would you feel? What if you did not have the disease yet and were not allowed to leave? What would you do? Would you feel your rights were being trumped? What about the rights of others in neighboring cities? Should they be potentially harmed because you want your freedom? What if other members of your family contracted the disease? Now what would you do? How would you feel? You then can follow this with real-life scenarios where this actually occurred. Or you could perform a hands-on interactive simulation demonstrating to students how fast infectious diseases can spread. Another intriguing element of emotional states and learning is the age-old question of why did they make this poor decision even though they know better. It could be they chose to not study for a test, not wear their helmet when they're skateboarding, or sneak out of the house when they weren't supposed to be. The answer lies in the fact that they have not developed enough experiences yet to care about the consequences. They very well may be cognizant that there are consequences, but their desires may override the rationale. The only way to help them make these connections is to allow them the opportunity to create neural pathways to learn the new behaviors associated with the poor decisions. In essence, let them fail the test and experience the ramifications of their choice. Let them either fall and get hurt so they realize why wearing a helmet is essential for their safety. Of course, not to the point where they need to be hospitalized. And let them experience the potential wrath of their parents for sneaking out. The next time they will be posed with these potential situations, their decision-making will be more mature due to the additional neural pathways they grew from the learning experience and hopefully make wiser ones. This is why adults make more astute decisions. We learned from our past. So do our youth. Even poor decisions are a learning lesson. Another way to help them develop emotional connections to situations they may not have personal experience with, but without having them fall, fail, or fear parental fury, is via furnishing more descriptive or even graphic in nature imagery or stories. For example, drinking and driving. We don't want students to learn for themselves the consequences of drinking and driving. So here's where tapping into their emotional states can come in to create new neural pathways for them to learn not to drink and drive. Showing movies and photographs of drinking and driving. Inviting both victims and perpetrators of drunk driving to come into the classroom and share their horrific tales. Or having a group of students reenact a drunk driving incident are all powerful instructional strategies to elicit emotions. A word of caution when stimulating, arousing, and attempting to bring student emotions into the learning. If students are under stress or duress, their brain will shift into survival mode. This will inhibit the learning process because the only thing the brain is focusing on at that point is removing the cause of stress. This is not to imply that educators should avoid unhappy thoughts, history, or concepts, but what this is indicating is that factors such as whether or not student physiological needs are being met, like getting enough sleep, eating nutritional meals, having a safe home to go to, and feeling loved and wanted, will affect the learning. Other emotional factors will impede learning as well. For instance, if they're fighting with a friend or a significant other, whether there are events occurring in the home, such as an impending divorce or an unplanned move, if they're self-conscious about their appearance, such as a devastating haircut, poor opinions of their weight, not belonging to the in crowd, or a tragic morning awakening to a puberty-stricken breakout. All these toxic emotions can and will hamper learning and need to be considered and alleviated if possible. If an educator is aware of family problems or circumstances surrounding the learner, perhaps recommending discussing these with a school or clinical psychologist may help. If students are not getting enough food or nutritional meals, providing these meals to the learner at school and furnishing the family with specific agencies to assist may improve the student's psychological and physiological states. The point here is learning about your students and what is going on in their life. This can be accomplished by establishing a positive rapport with your learners. The brain learns by building neural pathways, and the best way to do this is by engendering learning experiences. Whenever we learn something new, neural pathways are reorganized or built. This is known as neuroplasticity. Our brains are not made of plastic, it simply means our brains have the phenomenal ability to grow and build neural networks when we learn. There are a few ways to burgeon these budding networks. The learning experiences must have meaning, be tied to emotions, provide instructional strategies which focus on doing. When students can physically experience the learning, they are more apt to building sustained neural pathways. The brain does not grow and build neural networks when it is in a passive state, such as listening to an ongoing lecture. According to Dr. Fisher, the brain must be in an active state to build these neural pathways. Therefore, having students participate in kinesthetic learning is more inclined to generating these neural superhighways. It is also normal for students to perform well at first after learning a new concept or skill, but later regress. The more students practice the learning, the more prone it will be to become converted into long-term memory. Repetition, repetition, repetition. This does not necessarily mean rote memorization, but affording students the opportunities to repetitious practice or rehearsal, reuse, review, and reflection upon the new learning. Students need to build and rebuild these neural pathways after learning a new concept or skill. One way to facilitate this as an educator is creating new and various contexts of the novel concept or skill in order for learners to identify the multifarious and interrelated ways the new learning applies and connects to various disciplines, life situations, and concepts. Many times, students may appear to be quite versed or confident in the new learning. However, after an assessment may demonstrate the reverse. This very well may be due to scaffolding. In the beginning of teaching a new concept or skill, educators utilize scaffolds to assist learners in understanding the new stimuli. After one to a few guided practices, teachers usually follow up with a summative assessment, and the results may not be impressive or promising. So what happened? Why is it that during guided or independent practices, students displayed mastery of the new learning, but when put into an assessment scenario, they portrayed a different picture? The answer may lie in the scaffolding. Slowly and gradually, educators should remove scaffolds rather than going for broke. In a learning environment supported by scaffolds, students feel less threatened and are more apt to taking risks and building their confidence. However, when the scaffolds are removed too quickly and students are expected to perform well without them, for a high-stakes grade, anxiety can set in. The support system for building confidence and independent, complex critical thinking and meaningful connections of the learning are now gone. By gradually removing these scaffolds, tiering the complexity levels of tasks related to the new concept or skill, and slowly increasing the amount of tasks one can perform independently to demonstrate mastery very well may help. This begs the question, what are ways to help students process, internalize, store, and retrieve information from their memory? We already discussed a few: connecting the learning to something meaningful and relevant to their life, attaching emotions to the learning, embedding more hands-on instructional approaches, providing scaffolds, and then gradually taking them away. Create various and new contextual experiences with the learning, and furnish ample opportunities to practice, reuse, reflect, and review the new learning. Another strategy is chunking the information disseminated. The old days of 55-minute lecture being the best method for teaching concepts and skills is now scientifically correlated to being effective. Dr. Miller's magic 7 number for chunking has recently been questioned. According to Dr. Cohen, young adults have the ability to chunk 4 pieces of information, and even less than that for young children. Too much information at one time can cause an information overload. The hippocampus can only handle so much stimuli at one time, and anything more simply behooves the learning process. Educators can avoid the information overload alarm by chunking material, breaking it up into several small parts. For example, when teaching about the Civil War, teach about one significant battle at a time rather than all at once in one or two seatings. Later, an educator can draw upon previously learned battles for application, analysis, and evaluation. Glucose levels also affect learning. The more complex and unfamiliar with the new learning, the more glucose the brain uses to process this new information. Therefore, the more breaks the brain needs in order to refresh itself. Moderate glucose levels enhance the learning process, but too much of it will hinder it. The brain needs its own recess to recover and rejuvenate from the learning process too. This is where getting enough sleep is essential. Having students get up and move around, give their neural networks a synap. The age-old expression, "let me sleep on it," is actually a wise decision. More brain-based learning is the fact that more brains are better than one. Learning in concert with others enhances the learning process. Humans are social beings. This extends to learning as well. When students collaborate and cooperate with others, they tend to be more engaged and motivated in the learning, perhaps because they feel they can relate more to their peers and vice versa, or feel less judged than when they are learning from the teacher. Whatever the reason, students are more inclined to display engagement and motivation in the learning when they are learning with others. Dr. Jensen suggests that educators incorporate various groupings instructionally in order to promote what he refers to as pro-social behaviors. Students can be exposed to various groups and individuals in order to learn how to get along and collaborate with different individuals they normally may not socialize with. Hopefully, this will open up their social repertoires and minds to others. Some of the flexible groupings can be via peer teaching, mentoring, partners, think, pair, share, problem-based learning groups, and cooperative groups. Attention is integral in the learning process as well. Attention levels will differ, and are you ready for this? We are not in control of our attention. It is tied to our neurology. Some people can read a book with the TV blasting in the background, whereas others need a quiet place to reflect and sit. Attention works like a pendulum. On one end, it is inhibiting or buffering out the stimuli that is distracting the learning, and on the other, it is facilitating or enhancing the stimuli that we need to concentrate on. As you are watching this presentation, you may be buffering out the screaming child, reality TV bites, and the burning roast in the oven. Or you may be watching this over a nice cup of cocoa in bed before going to sleep, where the only noise is the neighbor's dog barking in the background. Regardless, all our attention levels will differ, and we cannot help that. Our brains are simply wired that way. So how can educators get and sustain attention? Don't just tell, show. In other words, use imagery to accompany words. Give students something to look at, like a map, photographs, slideshows, videos, cartoons, graphs, and so forth. Why? Dr. Medina explicates that looking at a visual and relating it immediately to a concept requires work. In other words, your attention. Some research suggests that lecturing or talking to students, rather than with them, for more than 10 to 15 minutes will obstruct the learning process. It involves encoding and associating, which engages attention and augments retention. Another way educators can captivate and keep attention is incorporating movement into instructional practice. Changes in the learning environment, such as getting out of your seat and moving to another area of the class, or moving the class outside or to a different room. Having students act out a scene, role play, perform a simulation, or do an experiment all get oxygen flowing to the brain, causing the brain to refresh or awaken, which in effect helps rejuvenate attention. Attention is linked to interest, So in order to cultivate and foster student interest in the material, give it a connection to their life. Lastly, differentiating instructional strategies to accommodate the various learning styles, multiple intelligences, interests, and academic readiness levels. Some students tend to gravitate toward kinesthetic learning modalities, where others may prefer visual or oral. Some may be more inclined toward logic and math, while others prefer music and art. Some may be better at learning during the day, and others late at night. Perhaps there is a need for collaborating with others, while others prefer working alone. Provide students with choices for how they wish to learn and demonstrate understanding of the concept or skill. One may want to write a play and act it out. Another may wish to compose a poem or rap, and another student may wish to create a multimedia presentation. The list can go on, but the point is significant. Educators cannot teach one way for one brain, but provide a rich learning environment that caters and fosters learning for a myriad of learning styles, diverse intelligences, socio-cultural backgrounds, physiological differences, and considerations. Another aspect of brain-based learning is the brain does not function in disparate parts, but as a synergistic whole. The once accepted and postulaticized left brain, right brain learner is now being questioned. Left brain learners were deemed more prone to being logical and the right brain more creative. However, with functional magnetic resonant imaging, it displays that regardless of whether one is thinking logically or creatively, both hemispheres are working in concert. There may be more activity occurring in one hemisphere than another during particular processes. However, to label a child as either left or right brain should now be challenged. The brain can process and perform a sundry of activities simultaneously and needs to see the whole picture along with the minute details. This is not to imply the meaning behind this synergistic activity endorses a whole language approach to reading versus phonics. It is simply to identify that the brain does not merely focus and perform one function at a time before it can understand a concept holistically. Throughout the course of one's lifetime, the brain continues to grow, develop, and learn. Dr. Fisher has proposed a new theory concerning how the brain's growth patterns developmentally correlate with cognitive growth. The ascribed stages of development begin with actions, representations, and finally abstractions. According to his research, this occurs across all disciplines. These critical periods of neural network growth occurs at 4, 8, 12 months of age, then 2, 4, 6, 10, 15, 20, and 25 years of age. Neuroimaging displays that these tend to be times of reorganizing of knowledge, building new knowledge, and thinking different. In order to facilitate these growth periods, educators need to create active learning experiences, learning by doing, such as experiential, discovery, and problem-based learning strategies. Let's not forget the effects of neuroplasticity on the adult brain. The aging brain also reorganizes and builds new neural pathways too. A few ways to facilitate this growth is to continue intellectually challenging oneself, reading, writing, doing puzzles, interacting and discussing stimuli with others, and exercise. Our brains are all unique. They develop and mature at different rates. Both nature, our genetics, and nurture, our environment, see to this. Both shape and develop our brains for learning, otherwise referred to as plasticity. Educators need to be cognizant of this. This is why differentiation is imperative. To accommodate the diverse levels or degrees of development and maturity, differentiation allows educators to tier content, instruction, and assessment. It furnishes diverse opportunities and choices for students to learn and demonstrate understanding of the topic according to their own readiness, neurology, physiology, and learning style needs. Some theories attest that childhood disease, environmental factors, and premature births affect brain development and maturity as well. If a student is struggling on mastering a concept or skill, do not reach in the learning disability hat and start pulling labels. Due to diverse developmental degrees, a student may struggle with mastering how to write letters, but may excel at putting pieces of a block puzzle together. The challenge for learning to write their letters may not reflect an inability to write, but a developmental inconsistency between their gross and fine motor skills. School curricula do not reflect these various brain, developmental, and maturity stages. As a result, educators will need to employ differentiation. For complex learning to occur, challenging experiences must be present, while threats to the learning should be eradicated or removed. Allow students to discover the answers of conceptual learning for themselves. Educators can do this utilizing discovery-based learning, experiential learning, and problem-based learning, just to name a few. However, if a learner feels threatened and too anxious, any learning will be inhibited or moot. For example, if they failed a test, received a negative comment from a teacher, or are spending an exorbitant amount of time trying to master a mathematical concept on the board when everyone else is in the class finished, all these events can impede the learning process. Educators should monitor student emotional levels and behavior. If a student appears to be stressed or anxious, affording them the opportunity to take a break and return when ready, sending them to a counselor, or talking alone and privately with them may help. If a student is academically struggling, furnish more scaffolds or other differentiating tactics. Lastly, educators need to be cognizant to the types of feedback they provide to their learners. If it is sarcastic and negative, the student will not respond positively and it may inhibit their learning. Address inappropriate behaviors and poor academic performance in private. The key is to remove the stimuli. Thus far, this presentation has identified common denominators permeating the diverse fields contributing to brain-based learning. However, the essential element to remember is that these are considered correlates, not definitive canons for educators to indoctrinate in their pedagogy. The instructional recommendations I furnished are just that, recommendations based upon brain research findings. With that being stated now, it's time to address the differences. According to some brain-based learning theorists, there are 12 underlying principles governing their domain. Many of them are shared to some degree by various theorists and fields. However, some are disputed. The overarching dilemma is when something is stated as being verified by evidence-based brain research, but in reality, this may be fallacious or tenuous. There is a difference between studies showing correlation versus causation, and in many cases, when it is demonstrating correlation, some researchers have prophesized it as a causation. There are some tenets researchers in various fields advance as true, however others have uncovered it to be potentially false. Whatever the truth is, the rest of these principles should be probed through a cautious scholar's lens. Many reputable and acclaimed researchers have subscribed to these principles, and much of their laborious work went into the foundations of brain-based learning. Therefore, academic scrutiny should be employed respectfully. The 12 principles were deduced by Drs. Kane and Kane, and they include the following. The brain is a parallel processor. It can perform several activities at once. The brain perceives wholes and parts simultaneously. Information is stored in multiple areas of the brain and can be retrieved through multiple memory and neural pathways. Learning engages the whole body. All learning is mind-body. Movement, foods, attention cycles, and chemicals modulate learning. Human search for meaning is innate. The search for meaning comes through patterning. Emotions are critical to patterning and drive our attention, meaning, and memory. Meaning is more important than just information, and learning involves focused attention and peripheral perception. The peripheral perception is all the things in an environment that affect our learning. It could be the movie going on in the background, The student gossiping about the girl next to her about her out-of-style shoes, the beautiful chirping bird perched on a tree, the way the lightning is shaped in the sky during a storm, or the pleasant and encouraging reaction of the teacher when someone may make a mistake. All these things go into the periphery, and therefore educators need to attend to these potential stimuli and ascertain they too help imbibe and support the learning environment. We have two types of memory, spatial and rote. Spatial, also known as autobiographical, does not require extensive rehearsal to remember, whereas rote is based upon the old-fashioned memorize these 20 scientific terms on Monday and take a quiz on them Friday. Word of caution here, we memorize the multiplication tables and this usually works. We remember them. But the point here is to ensure that students also learn the concepts behind multiplication as well. There needs to be a personal connection, meaning ascribed to the learning, putting the new learning in a variety of novel contexts and align them to real-world applications. This way, it will be more apt to being terminally remembered. Continuing with our 12 principles, we understand best when facts are embedded in natural spatial memory. The brain is social, it develops better in concert with other brains. Complex learning is enhanced by challenge and inhibited by stress. Every brain is uniquely organized. Learning is developmental. As you can see, many are consensually agreed upon by the sundry of theorists and researchers surrounding brain-based research, theory, or learning. Alas, some are disparate, and some neuroscientists as well as others attest that these should not be labeled as principles, but perhaps correlates. There are other facets like right versus left brain learners that are not necessarily shared by the research masses. Also things such as the concept of multiple intelligences, learning styles, that we use only 10% of our brains. And the only critical periods in one's life for learning is from ages 0 to 3. Regardless to what you subscribe, the point of this presentation is to shed light and reflection upon adopted pedagogical methods